Welcome back, class. Today we are going to be looking at 1-5, solving inequalities. Our first part this morning, we are going to be writing and graphing inequalities. The first inequality we are going to look at is x is greater than 3. To write that in a sentence, it looks like x is greater than 3. To graph x is greater than 3, we need to have our number line. Make sure you always place 0, and then 3 is to the right of 0. And then since it's just greater than, it's an open circle, and then you color in everything to the right of 3. So that's what the graph for x is greater than 3 looks like. Now the last thing we have to talk about is this new thing called interval notation, and this isn't in your book, so make sure you're taking really good notes. If you're looking at this number line that we just graphed, on the left-hand side is negative infinity, and to the right-hand side is positive infinity. So we read graphs from left to right, so I have nothing, 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 and then the first thing I come to is my open dot at 3. Since it's an open dot at 3, it gets a parenthesis, and then after 3 it doesn't stop until it gets to positive infinity, so you do 3 comma infinity and another parenthesis. Always at infinities you get a parenthesis, so that's how you write your interval notation for that inequality. Our next inequality is x is greater than or equal to -1. So whenever it's equal to, you have this line under your inequality. Now to graph x is greater than -1, I draw my number line. I place my 0. -1 is to the left of 0. Since it's greater than or equal to, instead of getting an open dot, it gets a colored in dot at -1. And then since 0 is greater than -1, we shade everything to the right-hand side of -1. So now on to our interval notation. Again, we always start on the left-hand side of our graph, and we have nothing, 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 and then the first thing we come to is -1. So that's the first part of our interval notation. Now, since our dot is colored in, since it's greater than or equal to, instead of a parentheses, it actually gets a bracket now. And then after the -1, your graph is all colored in, and it's not going to stop until it gets to positive infinity. So infinity goes on the right-hand side, and remember, infinities always get parentheses. Our next inequality is x is less than -5. To draw the graph of this, I need to make my number line, place my 0. -5 should be to the left of 0. So now, since it's just less than, again, it's going to get an open circle. You only get a colored in circle when it's equal to. And 0 is not less than -5, so that means I'm going to shade the other side of my number line. So now let's talk about our interval notation. So I'm going to add my negative infinity and positive infinity just so we can talk about it. So now we start on the left-hand side, and if you notice, my graph is already colored in on my left-hand side. So this time I start with negative infinity. Remember, any infinity always gets a parentheses. And then when you move to the right, the last place your graph is going to stop at is -5. And then since it's an open circle, I get a parentheses there as well. Our last inequality we are going to look at while we are writing and graphing these is x is less than or equal to 2. So now let's draw a graph of that. So I have my number line, I have 0, 2 is to the right of 0. Since it's less than or equal to, it gets a colored in dot at 2. And then since 0 is less than 2, I get to shade the left-hand side of my number line. So now let's talk about its interval notation. Again, you start on the left-hand side of your graph, and it's already colored in there, so we start with negative infinity. And then we move to the right, and the last place your graph stops at is 2. And since it's a colored in dot, since it's equal to, it gets a bracket this time. Now we are going to be writing an inequality from our sentence. So let's look at our first example. So the quotient of a number and 3 is no more than 15. And now we need to write it as an inequality. So quotient means to divide, and then since we don't know what that number is that it's referencing, right here we are going to use a variable for this number. So maybe x, any variable you want to. So since quotient means to divide, we're going to divide x by the number 3. And then since it says this key word right here, no more than, that means it can't be more than 15, so it's at least going to be less than. Now, since it could actually be 15, we are going to do less than or equal to, and then our number 15. Our next example is a you try problem, so press pause and I want you to write 6 more than a number is at least 23 as an inequality right now. Again, since I don't want my number is, I'm going to use some variable, so pick whichever variable you want to. I'm going to again use the number x. And then more than is a way for us to write addition, and then it's going to be more than 6. And then next keyword says it is at least 23, so that means it could be greater than 23. And again, since it's at least, that means it could also be the number 23, so it's going to be greater than or equal to, and then the number 23. Most of the properties of inequalities are the same as the properties for the equations, but 2 of them are different, multiplication and division. So let's go ahead and let's look at those. The best way for me to show you this property is to look at an example. So if you had negative 1/2 x is greater than 4, and you were trying to solve for x, you would have to get rid of that negative 1/2. So since it's a fraction, we multiply by the reciprocal. So the reciprocal of negative 1/2 is the same thing as negative 2 over 1, which is the same thing as negative 2. So since I have to multiply both sides by a negative number, that makes your inequality flip its direction and it makes it point the other way. So now my answer is x is less than negative 8. The same thing is true when we're talking about division in our inequalities. So again, I'm going to show you an example so that you can easily see what happens. So I have negative 3x is less than or equal to 9. So to get rid of that negative 3 in front of my x, I have to divide by negative 3. And just like in my multiplication, if you multiply by a negative number or if you divide by a negative number, it is going to end up switching your inequality, so it's going to make it point the other way. And then 9 divided by negative 3 gives me negative 3. So my inequality is x is greater than negative 3. So just make a note that if you're multiplying by a negative number or if you're dividing by a negative number, it makes your inequality point the other way when you do that part. Now let's look at solving and graphing an inequality. So when I showed you your multiplication and your division property, I did some basic ones, so we're going to build on it and make it a little harder now. So example 3 is negative 2 times the quantity x plus 9 plus 5 is greater than or equal to 3. So we are trying to solve for x, so we actually need to get everything away from our x. So there's multiple ways of starting it. You might see the distributive property, or you might see moving the 5 and dividing by negative 2. So either way, you are going to get the same thing. I am going to start by using our distributive property. So negative 2 times x is negative 2x. Negative 2 times positive 9 gives me negative 18. I have nothing to do with my 5, so I bring down my 5, bring down my inequality, and my number. So now, if you look on your left-hand side, you have 2 numbers over here, so we need to combine like terms. So that gives me negative 2x, and then negative 18 plus 5 should give me negative 13. Again, bring down your inequality, bring down your number. So now it should be a very basic equation, but it just has our inequality. So to move negative 13 to the other side, we need to add 13. So bring down your negative 2x, your greater than or equal to, and 3 plus 13 gives me 16. So now to get rid of my negative 2 that's touching my x, I'm going to need to divide by negative 2. And again, guys, I need you to pay attention because we divided by a negative number. So it's going to take my inequality sign, it's going to make it point the other way, and 16 divided by 2 gives me negative 8. So now let's practice graphing this. So draw your number line. I always want you to place 0 on your number line so I know that you know where the numbers are going. And then negative 8 is going on the left-hand side. Since it's less than or equal to, it gets a colored in dot at negative 8. So since 0 is not less than or equal to negative 8, I need to color the other side. So that's the left-hand side. So now this is what our graph is going to look like. So now let's practice writing our answer in interval notation. I have negative infinity over here on my left-hand side, positive infinity on my right-hand side. When you start on your left-hand side, if you notice, you already have a graph. So I start with negative infinity. Remember, infinities always get parentheses. And then your graph stops when you get to negative 8, so that's our last number. And again, since it is less than or equal to, it is going to get a bracket for your answer. So example number 4 is a you-try problem. So press pause, and I want you to solve for x in the problem. 4 times the quantity x plus 3 minus 1 is less than negative 2 times the quantity 3x minus 6. So let's see if we got the right answer. So I'm going to start by using my distributive property. So 4 times x is 4x. 4 times 3 is positive 12. Bring down your minus 1. Bring down your less than sign. So now on my right-hand side, again, I need to use my distributive property. Negative 2 times 3x gives me negative 6x. Negative 2 times negative 6, be very careful there, is going to give you positive 12. Now, let's combine like terms on each side of our equation. So I have positive 12 minus 1, so that's going to simplify to 4x plus 11 less than, and then I have nothing to do on my right-hand side, so I need to just bring down my negative 6x and my plus 12. So I have 4x on my left-hand side, negative 6x on my right-hand side. Again, I always like moving the smallest variable, but if you do it the other way, you should get the exact same answer. So the opposite of negative 6 is positive 6. So 4x plus 6x gives me 10x. Bring down your plus 11, bring down your less than side, and you're just left with 12 on your right-hand side. So now, since you have your x's on the left-hand side, I need to move my numbers to the right-hand side. So the opposite of positive 11 is negative 11, and 12 minus 11 gives me 1. So now to get rid of my 10 that is in front of my x, I divide by 10. If you notice here, I'm dividing by a positive number though, so it should not change the way my inequality is pointing. And since you can't simplify 1 divided by 10, leave it as 1/10. So my inequality is x is less than 1/10. So let's practice drawing this on our graph over here. So I have 0. 1/10 should be to the right of 0. It's positive. Since it's just less than, it gets an open circle at 1/10. And 0 is less than 1/10, so we are going to color in the left-hand side of our inequality. Now let's practice our interval notation. So again, you always start on the left-hand side, and you have a graph there. So I write negative infinity, and it gets a parentheses. And then my graph is going to stop when I get to 1/10, so that's my last number. And since it's just less than, it also gets a parenthesis as well. Our next part is no solutions or all real numbers as a solution. So let's look at example 5. So 4 times the quantity 2x minus 3 is less than 8 times the quantity of x plus 1. So I'm going to just start with my distributive property, 4 times 2x gives me 8x. And then 4 times negative 3 gives me negative 12. Bring down your less than sign. 8 times x gives me 8x. 8 times 1 gives you 8. So now look at both sides of the equation. They both have an 8x on them, so we're going to cancel that out. So I'm left with negative 12 is less than 8. Is that a true statement? Yes, so this is going to always be true. So if you were looking at that on a number line for it to always be true, your entire number line is actually going to be colored in because any value of x would make this statement true. So that means that your answer is going to be all real numbers. So in interval notation, all real numbers, or your entire number line is negative infinity to positive infinity. Example 6 is a you-try problem, so I want you to go ahead and press pause and solve 2 times the quantity of 6x plus 5 is greater than 4 times the quantity of 3x plus 4. Let's check your answer. So let's start with our distributive properties. So I have 2 times 6x gives me 12x, and then 2 times positive 5 gives me 10. Bring down your inequality. Let's use our distributive property again. 4 times 3x is 12x, and then 4 times 4 gives me plus 16. Again, on both sides, there's a 12x, so I can cancel those out. Bring down your 10 is greater than 16. Is 10 ever going to be greater than 16? No. So this is never true. So if you had a number line here, there is actually going to be nothing colored in on your number line because no matter what value of x we pick, it is never going to make this number true. So therefore, we have no solution to this problem.